Are you interested in running REPRAP firmware on your Ender 3, but you need it to be as easy as possible to configure? Well, today we're going to take a look at a mainboard that might be the one for you. What's up everyone, Chris here, and a while back we did a video where we ran REPRAP firmware on an SKR board. All you had to do was get a Wi-Fi module, plug it into your LCD connections, and then run a branch of REPRAP that was created by Team Gloomy. Well, they've partnered up with FlyMaker to create a board that integrates all of these options into one. And I have to say, this is the most affordable and easiest way to run REPRAP on a machine like an Ender 3 that I have ever seen. So that's what we're going to do today. We're going to take a look at the board and the features that you might be interested in, get it installed and configured, and hopefully I'm going to make this as easy as possible. So let's get right to it and check this board out. This is the Fly RRF-E3, and it runs around $30 US. You can get FlyMaker drivers as well as a screen. We'll talk more about that in a moment, but let's just start with the hardware a bit. Let's start with the processor. This is an STM32. It's an F407 VGT6. It runs at 168 MHz, and it has 1024K of memory. This is the same chip that Big Tree Tech uses for their SKR Pro and the GTR board, I believe. This board is designed to be a drop-in replacement for the Ender 3, but of course you can use it for a lot of different boards, and with REPRAP it's easy to configure those options, but we'll walk through all of that. Just kind of going around here, you do have 4 sockets for your drivers. You can use any one you wish, and it does have integrated UART, so you don't have to use jumpers for all your features, like controlling the current or sensorless homing. You also do get 2 Z plugs. You have your micro SD slot, you have a mini USB jack, just like on the Ender 3, and this port here is so you can use the FlyMaker style touchscreen. They do still have the connection where you can use a screen like a 12864, like that is on an Ender 3. Not exactly sure how that works with the firmware yet, but we'll take a look. You have pins that will support your BL Touch. You have pins that will support a PT100 thermocouple, as well as all the standard thermistor pins, bed, hot end, all of your Y end stops. You have an always on fan right here, and then you have 2 PWM controlled fans right here, which I like to see because you can use one for your hot end, the other one for your part fan. You don't have to have that hot end fan on all the time. And then you can use this always on for your controller board fan if you wish. We have our hot end terminal, our bed terminal, and then a set of always on terminals, and then our power input. The MOSFETs over here are 50V60As, and if you wanted to use these screen pins over here for something like a TFT, you could do that as well. Now let's take a look at the back. We have our Wi-Fi module. The board does come with an external antenna. If you'd like to use that, you can plug it in right there. Might be a good idea inside that case on the Ender 3. This is an 8266 module. And you also have a port back here for expansion, like you'd see on a DuX board for a duet. And most everything you need to know about these pins, there is badging for them back here, as well as there is documentation. This PCB is also 4 layers thick. And as I stated, you can also buy drivers from FlyMaker if you wish. I actually kind of like these. Any driver is going to be compatible with that board. It has jumpers where you can control them no matter what. But they don't have compatibility with that diag pin. So just like on an SKR 1.4, you'd have to bend or clip that diag pin if you're not going to use sensorless homing. But with the FlyMaker drivers, if you flip it over, they have a dip switch right here. So today, on this install for the Ender 3, we're not going to use sensorless homing. So rather than have to butcher that pin, we can just tick this switch down. It'll disable that diag pin, and the end stops will continue to work just fine. I really like that feature. And these aren't any more expensive than any of the other brands of drivers. And just a quick look at the FlyMaker 4.3-inch screen. It's a lot like a panel do. We can take a look at the back. It connects up a lot in the same way. And just to give you an idea of what we're dealing with money-wise, which I don't normally do, but I do think there is some value here. Maybe not with the screen, but the board, like I said already, is right at 30 bucks. You can add 4 2209 drivers. That takes it up to 50. And if you want all of it together, including the screen, it's 95. So even leaving the screen out, 50 bucks for this type of board isn't a bad deal at all. So just from the first look at the board and the manual, it looks pretty easy to configure, and I like what I see, and it appears to be very cost effective. So now we're going to go ahead and get the board configured, put the drivers and the jumpers on, and then we're going to install it in my old Ender 3 right here. It's been through a lot, but one more board can't hurt. So let's get to it. So for our drivers, we can run in 3 modes. We have standalone mode, where we control everything with the jumpers. Then we have UART mode and SPI mode. SPI would only be for things like 2130s. The normal or standalone jumper mode would be things for like A4988s or 8825s, things that aren't considered smart drivers. And then UART mode is what we're going to use today. You can use that on a 2208, 2209, 2225s, 2226s. So let's just go through all those jumper configs real quick. So I'm just doing one driver to show you. Normal mode for your A4988s, 16 times microstepping. That would be all 4 of these jumpers on. That'd be the same for an 8825, only that would be 32 times microstepping. SPI mode would be the same thing, only down 1 pin. You still have all 4 of these on the lower 2 rows. And then UART mode is the one we are going to use today. That is the lower 2 pins on this second set right here. That's the only one you need. So that's for your 2209s, 2208s, and etc. So there's all 4 configured for UART. And like I said before, we're going to be using these Fly 2209s, and they have dip switches on the bottom, and we're going to just turn centerless homing off for all of them. So it's the switch right here. I just have it moved to the down position. Now you can use any driver you want for this configuration, but if you don't want to use centerless homing, you're going to have to do something with that diag pin. Either clip it or bend it. And when you're using smart drivers like this, when they do have a diag pin, extra pins in here, they're real easy to line up because those extra pins go right in here. It's a lot harder to get them flipped. But all of the pins are spelled out here on the side if you need to know which way to install your driver. There's the enable pin up there. These drivers have the enable pin marked right up there. So they go on right like this. And in UART mode, we'll be able to control the amperage and a few other things. You could use centerless homing if you wanted to, but if you don't, if you want to do standalone mode, there's a potentiometer on these up here. You can set the reference voltage for your current. All of our drivers are installed, and you can also use these drivers on another board if you want to. The pins are available, so you can interface with those diag pins. There's a couple facing up. You have the UART connection pins down here too, if you want to use those on something else. But it's all integrated on this one, makes it very convenient. And one thing you'll have to do if you only want to use one Z motor, like on the Ender 3, on this second Z driver plug, you'll have to put caps on those pins. Cap on those 2, and a cap on those 2. Because you're not running a second Z motor, you're not going to complete the circuit. This is exactly how duet boards are configured. Now we're ready to install it on the printer. So here we are at the printer, and something you've probably seen me do a lot on the channel is put boards inside an Ender 3. But any printer that you find that just has soldered ends on the wires, you either need to put a ferrule on there or use the bare wire if you have to. You don't want to put soldered tinned ends like this underneath a terminal. So while you're doing this install, you might want to go ahead and take care of that. I'm going to show you where all the wires go, but I'm not necessarily going to use this as a production install. But definitely consider doing one of those 2 things if you're going to do something like this. I like to put the input power wires on before I put the board in, just because I think it's easier. But those are really the only 2 that are kind of hard to get to. So now we can go ahead and slide it in. It mounts in the stock locations. You got a screw here, one up here in between the wires, and one down here by the SD card. So our board is in and screwed into place. Remember, if you want to use that Wi-Fi antenna, that connection is on the back. You'll want to hook that up before you put it in. I'm not going to use it for this video, but it might be handy in this configuration, depending on how far away you are from your router. So we'll just work our way around. We're going to skip this set. These are always on. On an Ender 3, a lot of times this will be the fan. We're going to do that a bit different here today since we have 2 PWM outputs. The next one, these 2 are going to be for your bed, and these 2 are going to be for your hot end. So there's the heat bed back here. We got positive, then negative, and then these 2, those are for your hot end heater. They're not polarized, it doesn't matter which one goes where. Now let's talk about fans. These 2 right here, these are the ones that are PWM controlled. This is fan 0. This one you want for your part cooling fan. You have positive and then negative. So that's your yellow and blue wire on the Ender 3. It goes right there. And then this one up here is fan 1. We're going to use that for the hot end. Now on an Ender 3, you have wires that are stuck in this terminal way back here, this always on terminal. So that hot end fan always runs. Now we can control it with these PWM pins. So I put a JST connector on my hot end fan connection, and I'm just going to park it right here. Positive and negative. Now we can control it in the firmware. This is the other fan, fan 2. It's always on. We'll use that for our controller board fan, the one that's on the outside of the cover that goes on this case. Next one down right here, we have our X in-stop connection. I am not using centerless homing in this configuration. We will use the switches. So there's X. Next one is Y. There's Y. And then Z. There's Z. Then we have our thermistors. Our bed is right here. Our hot end is right here. So we'll plug in the bed. Remember, they're not polarized. Right there. And then the hot end thermistor. Right there. Then we'll move to this side and do the motors. We'll just start at the bottom here with the extruder motor. Right there. Next we have our Z right here. We'll just push it in. Then you guessed it, we'll move the next one up. That is Y. Right there. And then above that we have X. Right in that slot. Now I am going to go ahead and plug in my LCD cable. I don't know if the software can utilize it yet, but we might as well while we're here. It's hard to see, but it is down here. It's an EXP3 connection, just like on a Creality printer. I am also going to plug in that 4.3-inch touchscreen that they gave me to use with this board. It goes right in here, and they're going to give you a cable that has a JST connection that is compatible with that screen. They should give you enough cable to run over to the stock LCD location if that's where you want to mount it. This one's about 40 centimeters long. So that's pretty much all there is for the hardware install. We do have to put the case back together. It has a fan on it. I'll show you where I'm going to plug that in, as well as the touchscreen. We'll take a look at that. But all in all, it's pretty straightforward. And with all the work that the team has done with the firmware, it's pretty straightforward as well. So let's move into that. You will need to provide your own SD card, but pretty much any SD card will work for this configuration. Now, there's a lot of great information out here for this board, these configurations, everything you might need to know as far as configuring drivers, BL touch sensors, the works. There's even a complete walkthrough for the Ender 3. But we do have to build a configuration, and you can use the REPRAP configuration tool. But Team Gloomy has come up with a custom configuration tool like you saw in the SKR video, but it now includes the STM32 baseboards. And in fact, there is a configuration right here for the Ender 3 for this Fly E3 board. So this makes things a lot easier. And if you have something that's close to Creality machine, I suggest you go ahead and build with this default Ender 3 profile for this board and then tweak it after the fact. It's going to save you a lot of work ahead of time. You can just use the config.g file after that to make your minor tweaks. So let's just go through it, but we shouldn't have to change much. So we'll select this configuration, we'll hit next. We have the config for the board. We are using REPRAP version 3. I don't like to put spaces in my printer names. I'm just going to take the space out, but we can leave it Ender 3. And I say that because you can use ender3.local after this is configured to call your printer. You don't even have to use the IP. You can configure an EEPROM setting with an override file if you want to. Sometimes that gets confusing, so I leave this off. And all this basic stuff is going to be set up for you. We have a Cartesian. It set up the sizes, 235, 235, 260. And it set some homing speeds for all the different moves. We'll hit next. We are using all of our in-stop switches, so we don't have a probe. You would set your Z probe settings down here if you wish. I have some other videos where we do that. If you'd like to check those out, I'll leave them in the description. Our fans are mapped out. We are using 0 and 1. Those are both PWM. And the heaters are set to the correct output and sensors. So we'll hit next. The default config is using a 2209. They have set these to 1200 milliamp. That shouldn't be an issue. These motors should be good to 1500, but you might want to back it down if you don't need that much torque, just to save you a little bit of noise. Again, it shouldn't be that big a deal, but always check to see if the motors are getting hot or something like that, and then back it down if you need to. You can do that after the fact. But all the steps per millimeters, max speed, all this should be good. This is a pretty solid config. You have your holding current down here, 30% at idle is good to have. We'll hit next. Your in-stop types, whether it's a probe or you're doing sensorless, we have all switches today. And they're all at the low end. So 000 is where all of our switches get triggered. If you triggered them in the max, that'd be these over here. Z-probe, we don't have a Z-probe today. We'll hit next. We do have a heated bed. We are using PID, and these PID settings are pretty good for these configurations, but you can go back and run the auto config later and fill them in if you wish. We'll hit next. We have our part cooling fan up here. That's fan 0. It is set to non-thermostatic controlled because we control it in G-code. And then our hot end fan on number 1, it is thermostatically controlled. We control it with E0 and it'll kick on at 45C. Hit next. Tool change preferences. This really doesn't matter for us. We only have one tool. But it is set up as the default 0. We'll hit next. Bed probing mesh is all right here if you'd like to set this up. We'll hit next. Now we have our screen configurations. You do have this 12864 display option right here. It is grayed out for this config, but we'll look at that towards the end of the video. I think we can still make that work. But we are going to test the Fly 4.3 touchscreen, so we'll go ahead and enable that. It'll put it in the config file for us. These pins are correct because this configuration, again, is for this board. We'll hit next. Password, I don't need a password, so I'm not going to fill this in. That's a password to protect your web UI. I do recommend that you configure your wireless network right here so you don't have to terminal in later. We want to make this as easy to use as possible. So I'll type in my network name. Remember, these are case sensitive. And then your Wi-Fi password. It sets all the pins for your 8266. All of these are default correct because this configuration was made for this board. We are going to acquire our IP with DHCP dynamically. We can use that .local address, so we don't care so much about the IP changing. And we have to enable HTTP interface to use that web GUI, or the DWC. So we'll hit next. And then finally, we want to get the latest Duet control version and get the latest stable REPRAP firmware version. We're going to go over that a bit more. I'm going to go show you how to grab it off of GitHub. But then, if you don't have any extra G-code you want to put in your config.g, you can always add it later if you want to. We can just hit finish. And here, I'm going to go ahead and download that Duet web control. I'll just click here. And we can download our whole configuration model right here. Now we do need to take all these files we downloaded and build our SD card. I am using a 16 gig card. You don't need one near that big, but you will store your G-code on it as well, the stuff you upload. So take that into consideration when you find an SD card for your config. But we also need some firmware. There's no firmware on these boards by default. So we just need the bin file that Team Gloomy has made for us. And there's a whole release page on the GitHub. I don't like to go for the pre-release. I like to use the stable one, so we'll scroll down a bit. Our latest release is 3.2. I think we did 3.1 something in the last video. But we need the one for the STM32 boards. So down below, we're going to select the one for STM32F4. And we're using an ESP8266 Wi-Fi. So we'll grab that one. And now let's build our SD card. So here's our brand new SD with nothing on it. We'll go ahead and copy that firmware.bin that we downloaded. Copy it from downloads. We'll paste it right here. This is the correct file, but it has to be named firmware.bin, so we need to rename it. We'll just take everything off except for firmware.bin. So we're good there. The first time we load this card and we power up, it's going to flash this firmware onto the board. Now let's grab our web control files, back to downloads. We'll extract all for that configuration we downloaded from the configuration tool. And we're just going to take everything that's in this zip. We'll copy it. Back to our SD card, we're going to create a folder called www. That's where everything for the web interface lives. And we'll paste all those files right here. So that should be good. Now we need to load our config. So back to downloads one more time. Extract all on our config.zip. And we have a sys directory with all our configuration files in it. We'll just copy this sys directory back to our SD card, and we'll paste it right here. You'll also need a couple of other folders, so let's create another new one. We need one called G-codes. That stores all the G-codes we upload. We need another one called filaments. And we need one more for macros. So we'll just call it macros. So now we do need a firmware for our Wi-Fi module, and that version that runs with this configuration is available out here. It's on the GitHub page. I'll have all the links directly to these files for you in the description below. But we need the one, we're going to use the latest release. It's 1.25, and we need the one for the STM board. It's this one right here. So we'll go ahead and download that. We'll head to downloads, and we'll just copy and put that over on our SD card. It needs to go in the sys directory, so we'll put it right here. And we need to take that version number off of it for that STM32. We'll just take this piece off. It needs to say duet Wi-Fi server.bin. So that should be good. Now, when we boot up, we're going to have to initiate these installs. It's going to install the firmware, we need it to install the Wi-Fi module, and it's going to prepare that www directory for first use. And you'll notice in this sys folder, we have something called runonce.g. And let's just open that up and have a look. So this is a file that the REPRAP configuration tool created that will only run once. It runs on the first boot and then it will get deleted. And this is so that it can disable the network and set it up so you don't have to have your network and password info in your config file. This should get you up and running on your network so you don't have to mess with it. Now you can do all of these commands in the terminal, and I'll show you a bit of that after we do this. But you can also kind of get tricky here and use it to install that firmware that goes on your Wi-Fi module. So we're going to fix it up a bit. So let's add a line to the top, and we're going to do a G4, this is dwell. And let's just wait for 60 seconds, so we'll do S60. That'll give the firmware a bit of time to install. We probably don't need 60 seconds, but we'll wait a little longer than we have to. Then let's initiate the Wi-Fi module install. We're going to do M997S1. That will go grab that bin file for the Wi-Fi server that we just put in the sys folder and install it on the module. And while that's working, let's go ahead and wait for it to get its job done. G4S60. It shouldn't even need 60 seconds, but we'll wait a little longer than we need to. Then we are going to disable the network, that module. We're going to wait 5 seconds. We're going to send the information we need for our network right here. Wait another 5, and then enable the network. Then you should be on the network ready to go. This is just a little trick that I like to do with the run once file, so you don't have to cable up to the board if you don't want to. Give it a try. Again, we'll look at the terminal commands here in a moment. So we'll just go ahead and save this. It's already on the SD card. Now let's head back to the printer. We'll mount our SD card and get our touchscreen set up. So we'll just load our SD card onto the board right there. Our touchscreen wire is already plugged in. Jay did send me this bezel that he created for these touchscreens, the ones from FlyMaker, they're 4.3. I'm going to use 4 M3 by 10 millimeter screws and some M3 nuts on the back to hold it on. The case does fit pretty well. And this plug that I already plugged in actually goes through the side over here. So our screws are on, and then we can go ahead and clip our cable back on here. It just goes right through this bezel, back into our plug. Right there, and this one's actually made to use the stock hardware that the Ender 3 has. So we'll just take the LCD off for now. And our new touchscreen will go right in its place. And there we go, touchscreen is installed. Now I'm going to go ahead and cable up USB and open up Pronterface before we boot up. So you can see a little bit more information of what it's doing while it's booting. You don't have to do this probably, only if you need to do some troubleshooting, but it should be interesting to see anyway. So I'll just cable up here. And we'll go ahead and power on and then head back to the computer. So the firmware flash was successful, or we wouldn't have been able to connect. Now you can see the Wi-Fi is reporting no known networks. It's going to go through an upgrade sequence here in a moment. We're still waiting that timeout. Now we're going through that update. Our 60 seconds is up. So we're running that M997 command. Update is complete, so it's going to go ahead and start the module, but our script is going to stop it, set our Wi-Fi info, and then start it again. And when you get this message right here in the terminal, it says done, you're ready to use your board, you should be up and running. You shouldn't even have to get into this terminal. Just put in your SD card. If your password's correct, just wait 4 or 5 minutes, then you can go over to your browser and log in. We'll do that next. You can see mine says wrong password because that's not the proper password, but I'm going to correct that, then we'll head over to the URL, and this should be all you have to do. When the password and the network information is correct, you should see it right here. It's going to give you the IP. We can use our ender3.local, or you can try this IP if you wish, if that's not working for you. Not every router supports it. But again, you can do all these commands from terminal. That M997S1, you can update it manually. M552S0 shuts the Wi-Fi module down, puts it in idle. M552S1, that enables it, and that should pick up your wireless network settings. I have a lot of this information in other videos, but if you follow my method, you shouldn't have to do this, hopefully. From here, we can open a new browser window. We'll do http://ender3.local. And that brings us to our DWC. And if you use that config like I did and the REPRAP configuration tool, everything should be already set up. The only thing we really have to tweak are the PID settings for the Hotend and the bed. And we do that with an auto command. Some things to note, I did go ahead and plug in the antenna they give you with this board to the bottom of the board. It would work down here, but it was pretty slow. Again, that's going to be determined by how far away you are from your Wi-Fi router. Mine's all the way upstairs. And let's check out this touchscreen just a little bit. So here's the default screen. You have your SD control. This is the onboard one. You can go back to print, and then you have your macros if you have any in your configuration. I currently don't. Over here we have a home button. This lets you home all. You can do motor stop, and it tells you where you're at on your printer. Right now we are at home. Heating, it's pretty self-explanatory. Nozzle, bed, you can raise or lower it right here. Then we'll go to move. You can manually make moves. You have an extruder tab, leveling, parameters. So you can set quite a few things in here. And then you can go to more. Now by default, more gets you into your Wi-Fi settings, and it's going to display your username and password for your SSID right off the bat. So we'll go ahead and go in there, and that tab is right up here, the default tab that you're going to go into. So that's one way to get your information and your IP. You also have firmware info and G-codes. G-codes over here will actually let you see the terminal items that have happened. This is the same thing like we saw in Pronterface. You can click on it. You'll get a keyboard where you can run some commands manually if you'd like. And then you have a screen set calibration screen if you want. You can change up the display, password, a couple things in there. So not a ton of options, but a really nice screen and a flow to how it works. It should be able to get everything that you need done. So back to the DWC, we're going to go ahead and run through those PID tunes, but before I forget, if you're going to use Pronterface to communicate with a duet board or anything REPRAP, be careful, because a lot of times when you're punching in your SSID or your password, it's going to be case sensitive, and Pronterface isn't all that good at it. If you make the command capital, like here we would use an M587, then everything should pan out. It should make all the cases correct. But a lot of times it's just easier to use another terminal editor that doesn't have that problem. You've seen this in my other videos, but the one that Duet and REPRAP recommend is called Yacht. Yet another terminal. I'll leave a link to this as well, but just be aware that Pronterface doesn't always do that great a job when working with REPRAP. Back to the DWC, we'll go to the console, and we're going to kick off our PID tune for our bed. So we'll just do M303, pick the heater with an H, so the bed is set to 0, and then the temperature you want to tune to, we're going to do S60. And we'll let that run. So the bed PID tuning is done. Now it did throw this warning about being consistent. I don't know if that's the bed causing this or the MOSFET, but for the bed it shouldn't be that big of a deal because most of the time we don't even use PID. We use bang bang on a lot of printers. That's just on and off. So it should work just fine, but we do need to update this command right here, this M307. There should already be one in the config file, but let's go ahead and update it with this one that it spit out. So we'll go to System, config.g, and if you're using this config, there is a heater section. Remember the H0 is the one for the bed, so let's just go right below our existing M307, paste our new one in here, and we'll delete our old one. And now your PID values should be stored for your bed. And we'll save that. No need to reset yet, we got to do the hot end. So back to console. Still the M303 command, but we're going to change to H1 for heater 1. That's our hot end. And let's tune it at 210. And we'll hit send. And our hot end auto tune is complete. We're going to do the same thing. We'll take this M307 command, we'll copy it, head back to system, config.g. We have this second 307 down here for E0. Underneath that, we'll paste our new one in, and we'll delete our old one. And that's a pretty solid config. You shouldn't have to tune anything else to get your Ender 3 up and working. Of course, if you're using a different printer, you're just starting with this config, you'll have a lot of things to change, but it's pretty solid all in all. So we'll go ahead and save now, and we'll let it reboot to bring those settings in permanently. So that's pretty much all there is to the configuration. You should be able to start printing now. And I know it probably seems that I went through it really quickly, but I will leave a list in the description of all the steps that you need to do to get this same thing done, one after another, and the different URLs you need to go to. Team Gloomy has done a great job at putting together some documentation to get all this done. And of course, you don't have to just use this on your Ender 3. You can use it on any printer. All you have to do is tweak that config.g file. But I do recommend, again, you start with that Ender 3 config. It is very well put together. Now, one of the biggest drawbacks to boards that run REPRAP is sometimes they don't have a lot of screens that are compatible with them. But this one, you can actually use that stock Ender 3 display because, again, Team Gloomy has put the work in to make menus to install on it. So let's get that configured now, because I think that's one of the biggest advantages to this board setup. So let's just switch back to our stock display. Not that there's anything wrong with this touchscreen, it is really nice, but a lot of people don't want to spend the money on it. We'll just use the stock screen that came with our Ender 3. So let's take this one off for now, put our stock display right back on. And while we're here, let's go ahead and close up the case. I'll show you where to plug the fan in on this board. So on the Ender 3, you have this case fan for the controller board. It just plugs into an always-on connection for this board. So in the same group of plugs here where you plug in your other fans, there's an always-on port right here. We'll plug our controller fan in just like that, and then we'll go ahead and close up shop. Now there is that external antenna. You could probably stick that on the side of the printer. I'm just going to leave it in the case because it does seem to be working okay with my config. But if you're having slow connection times, you might want to consider putting it in a different location. One thing I did notice is that my case fan collides with the Z and E drivers when you use these taller heat sinks. My board did include a couple of low profile ones, so I'll just go with these. They should still work just fine, especially since we have a fan that's going to be running all the time. So back to the DWC. Now, one thing you do have to do to get this screen working is upgrade. And the release of code that you need hasn't actually been released yet, but it should still work. It has been somewhat tested. So we're going to go back out to the GitHub, and we're currently at the latest release down here, this 3.2_1. We need 3.2_7. This one right here. And this is a good time for me to show you how to update these. So expand assets, we need the one for our STM32 board and our 8266 Wi-Fi, so it's this bin right here. And if we go back to the DWC, you should be able to go to System, and we're just going to hit Upload System Files, grab our new bin file that we just downloaded, hit Open. Once it's uploaded, it's going to know that it's the latest firmware version, so just hit Yes. When the update's complete, it'll reboot. If you go to Machine Specific, it'll tell you which version you're on. We're on 3.2_7. That's the one we need. Now we do need to tweak a few more configuration items now that the update is complete, so let's go back into System. We're going to head into board.txt. This is the file that adds all of the special items that you need to use some of these other boards, like this Fly board. But down here at the bottom, we just need to tell it what pins to use for our encoder and our screen. And that, again, is all available on their website. We're just going to grab all of these pins right here. We'll copy them back to the DWC, and we'll paste them right here at the end of board.txt. We're good there. Hit Save. Then we need to go to config.g and add the line that actually configures the screen. We'll head all the way to the bottom again. We have this line down here for our touchscreen support. That's just a TFT connection screen. You can leave that in there. But we need to add an M918. That's again right here on their website. We'll just take this whole command, copy it, add it in right there, and we'll save it, and we'll go ahead and let the board reboot. Now that it's back up, you see over here we have this display button. That's where we can add our menu files, but we do need to download those. So back to the website. It gives you a couple different methods of getting this done, but the menu files that they've created are right here. We'll open that up. We'll grab the zip file. That should be in your downloads. Back to the DWC. Then we'll head into display, the new option we have. And we're going to upload menu files. And we're just going to grab that whole zip file. You don't even need to unpack it. Just hit open. It's going to uncompress the whole thing. When it's complete, you can hit close. And now you should have a menu you can use on your stock display. And there it is. It's not much, but it's definitely enough to get you moving around where you can kick off a print, or at least stop it if something bad happened. That's what I run into the most. I do everything from the DWC, but then something fails, and I have to go back to the computer to stop it, or at least get out my cell phone. So, just something to have, and you've already got the display anyway on most of these machines, so this should work out just fine. So all we have left to do now is give it a test. Let's go ahead and home all. We've started to preheat. I did a quick level. We'll go ahead and load up some filament. We can go to Jobs and upload our G-code. And we are ready to print. So there it is, the Fly E3 board install is complete, running REPRAP firmware. You can use the DWC via Wi-Fi to control the whole thing. At this price, you probably can't beat this configuration, and you can even use the stock display if you want to. And this can't be possible without Team Gloomy and all the work that they have done. I can't wait to see what they do next. That is it for today, and I will see you very soon on the next one.